Okay, so here we're going to attempt to find out how long it takes for an investment to reach a certain amount. So we're going to use our compound interest formula. We know that the P value is the principal amount, which in this case is a $1,000 investment. It's a 4% annual interest rate that gets compounded monthly. And the question is, how many years does it take to reach $2,500? Okay, so 4% compounded monthly. With that, we're able to find our I value, because our I value is the interest rate divided by the number of compounding periods in a year, right? So the interest rate is, in this case, 4%, 0.04, divided by the number of compounding periods in a year. Since it's compounded monthly, that would mean we've got 12 months in a year, so this is compounded 12 times in a year. Okay? So this now allows us to find out what the I value is by taking 0.04 and dividing it by 12. Okay? So that gives us 0.003333. Okay? So that's my I value. Alright. I know that my P is 1,000. My I is now this number here. N is what I want to find. That's how long it takes to reach the value. A is how much I want the investment to become worth, which is 2,500. So what I end up with is 2,500 equals my principal, 1,000, times 1 plus I, which is this number here, exponent n. And my goal is to find out what n is. Okay? Lots of ways I could do this. Here's how I usually do it to keep it simple. Is I'll get rid of the 1,000 that's here first. I can do that by just dividing by 1,000 and canceling it off. Of course, if I do that to one side of the equation, then I need to do it on the other side of the equation to keep everything balanced. It's a balanced beam. So I divide 2,500 by 1,000 to give me 2.5. At this point, I can add together 1 plus 0.00333, so that gives me 1.003333. And my exponent is n. So to find out what this is now, what I'll do is take logarithms of both sides. It doesn't matter what base of logarithm I take. I could use base 10, base 2, base natural log if you want. Doesn't matter. So we'll take base 10 just to keep it simple. So take the logarithm of both sides. Okay. Now what I can do is I can apply my power law to bring this exponent down in front of the logarithm. So that gives me log of 2.5 equals n times log of 1.003333. So this is really just a number, so don't get scared by how ugly it looks. This is really kind of the same as having 2x equals 6. To find out what x is, I would just quite simply divide by the number that's multiplied by x, which in this case is 2, right? So in this case, I've got n times a number. So to get rid of this number that's stuck onto the n, I just divide by it, whatever it is. So in this case, it's log of 1.03333. That would cancel that off then. Of course, once I divide that side by the log of 1.00333, I need to divide the other side by the log of 1.003333. Okay? So this, of course, is then going to give me n is equal to the log of 2.5 over the log of 1.003333, which I can then evaluate using a calculator, right? So I would just punch in log 2.5, close off the bracket, divided by log of 1.003333, close off the bracket. And you notice that I get 275.37. For now, we'll just say 275. Okay? So 275. So what you notice actually is that this is not in years. This is actually, because this is compounded monthly, in months. So this is 275 months. Okay? So if you wanted to convert that to years, I would just take the 275 and divide by how many months are in a year. Which of course is 12. So I would just take 275 and divide it by 12. So then that comes out to be about 23 years. Okay?